If you've ever just stared at a list of programming languages, Python, Java, JavaScript, and felt, completely paralyzed, you're definitely not alone.
Hmm.
Our sources today really cut through all that noise. They lay out this structured step-by-step roadmap that's all about your actual career goals.
And what's so fascinating to me is how much they insist on logical thinking over syntax.
Right.
I mean, before you even type a single line of code, the idea is you have to get this foundational mindset down.
Okay, let's unpack that. So, phase one, the foundational mindset.
Yeah.
The sources are absolutely clear on this. You have to master how programming works conceptually first. We're talking algorithms, flowcharts, even just pseudocode.
So building that problem-solving muscle before you even have a tool, you know?
Exactly, a non-coding muscle. And that's why the roadmap gives you two choices for a first language, and they each serve a totally different purpose.
So you have Python.
Right, Python, which is praised for its simple syntax, super beginner-friendly.
And then you have C.
Yeah, and C is for someone who really needs to understand how memory and hardware work from day one.
So the goal isn't just to learn a language, it's to learn how to think like a programmer.
Precisely.
So phase one teaches you how to think. Then phase two is where you learn to think efficiently.
Ah, okay.
This is a huge step, mastering data structures and algorithms, or DSA. The sources basically say this is non-negotiable for job interviews, for strong logic, for writing good code.
And for that, you'd use something like C++, Java, or even Python again, right?
Yeah, those are the common ones for this stage.
But this next phase, phase three, this is where it gets really interesting for me. Specialization.
Right.
After DSA is solid, you kind of pivot completely to tools for a specific domain. So let's take the web development track first.
Okay, so for a full stack developer, you obviously need HTML, CSS, and JavaScript for all the visual stuff, the front end.
Of course.
But for the back end, you're then looking at very specific frameworks like Python's Django or Flask. Or you could stick with JavaScript and use Node.js.
And you also have to master things like REST APIs.
Yes, which is basically how the front and back ends talk to each other.
Okay.
And then databases like MySQL or MongoDB.
Okay, so that's one whole universe. Now let's pivot completely. What about the data science and AI path?
That's a totally different toolkit. Python is pretty much mandatory there.
Right.
But the focus is all on its ecosystem. You're using libraries like NumPy and Pandas just for data analysis, and then these massive frameworks like TensorFlow or PyTorch for actually training models.
So the specialization dictates the tools, not the other way around.
Exactly. And once those tools are chosen, the roadmap moves past coding into the professional environment itself. That's phases 4 and 5.
Industry readiness.
Yep. For instance, version control, so Git in GitHub. It's not just a skill you learn. If you're an AI, you're using Git to manage model checkpoints. In web dev, you're using it for team collaboration and deployment.
So given this ideal path, what are the biggest traps or mistakes the sources say people should avoid?
Oh, they're very specific. The big one is trying to learn too many languages at once.
I can see that.
Also, skipping those fundamentals we just talked about.
Yeah.
And maybe most importantly, just chasing certificates instead of building actual skills you can show.
So the focus has to be on what? Projects.
Real-world projects. Build a portfolio website,
Mm-hmm.
write some automation scripts, get an internship to get that crucial real-world exposure.
Okay, so let's just tie this all together. The big insight here seems to be that there is no best programming language.
Not at all.
The best language is just the one that directly gets you to your specific career goal.
And the success formula they lay out is so clear. It's strong fundamentals plus one main language plus real projects. That equals success.
That's a powerful equation. And it leaves me with this one final thought to mull over. The sources briefly mention languages like Rust and Go for really high-performance systems, operating systems or game engine.
The really low-level stuff.
So, if web and data science get by just fine with these high-level languages like JavaScript and Python, what deep architectural differences must exist that make C, C++, Rust and Go absolutely necessary for those high-performance systems? Something to think about as you map your own path.